Assalamu alaikum. May the peace of Almighty God be with you all. You're welcome again. Now we are going to apply our formula to solve one or two problems. Be rest assured that the essence of doing this is to make sure we solve lots of examples that will make it easy for you to handle any calculation that comes from this particular topic. So let's get started. The first question here is, a wire 20 meter long is heated from a temperature of 5 degrees Celsius to 55 degrees Celsius. If the change in length is 0.020 meter, calculate the linear expansivity of the wire. So from this, you should know a wire of length this is heated. So from here it was not heated. That gives us our original length. It's heated from a temperature of this to this. This gives us what? Our original temperature, and this gives us our final temperature. If the change in length, remember I told you delta L is what? Change in length. So that is change in length. Calculate the linear expansivity. This is what I'm looking for. If you are able to identify each of the parameters, you have no problem. The next thing is to what? To recall your formula, input them, and solve. Now, solution. Let's take our known. What we know is that our original length, L0, is 20 meter, and initial temperature, θ1, is 5 degrees Celsius, θ2 is 55 degrees Celsius, for you to see. Then, what else? Our change in length is 0.020 meters. Then what is the unknown? Unknown is nothing but what? Linear expansivity. This is what we are looking for. So the next step is to what? Recall the formula. Recall that alpha is equal to change in length all over original length into change in theta, θ2 minus what? θ1. Remember that this is the same thing as L2 minus L0. So if I have recalled my formula, then I'm looking for alpha. Yes, alpha equal to change in length is given to be what? 0.020 all over L0. I'm talking about this place is what? 20 into θ2 is what? 55 minus what? θ1, which is what? 5. Are we clear? Now, this is alpha equal to 0.020 all over 20 multiplied by difference of 55 and 5 to give us what? 50. Is that clear? Now, the next thing is what? Alpha is equal to 0.020 all over, what is 20 by 50? You put it. That is, we are going to have 1, 0, 0, 0, right? Yes. Is that correct? Good. So the next thing is to divide this by this. So alpha is equal to, be sure of what we are doing in exam. So divided by this, that will give us 2 times 10 raised to power minus 5. Please don't forget to put your unit. It's very, very important in physics. So per what? Degrees Celsius. So my work is in degree, so I'm going to use degrees Celsius here. I can also use, it's the same thing as being in Kelvin, no cause for alarm. Is that clear? So that is for this, how to find the linear expansivity using your formula. The next one is a metal rod of length 100 centimeter is heated through 100 degrees Celsius. Calculate the change in length of the rod. Compare this question with this question. You see, you have two temperatures here, right? But here it's heated through this temperature. This shows that your differences in the final temperature and the initial temperature has been given to you. That is the change in what? Temperature, or we can call it what? Temperature rise. Are we clear? So that is there. Now, a metal rod of length this, identify that this is your what? Original length, L0. The change in length, calculate the change in length. You should know that you are looking for what? Theta L. Given that linear expansivity is this. If you have identified this, you have no problem. The next thing is to what? Recall your formula. The same formula. So here, let's bring out our known. As usual, known, we have L0 is 100 centimeter. We have change in theta to be what? 100 degrees Celsius. Then we have alpha of the material, which is rod in this case, is 3 times 10 raised to power minus 5 per Kelvin. I told you, it's of no offense. Here is per Kelvin, here is this. You don't need to change any, they are the same. Is that clear? Then what is the unknown? Unknown here is we are looking for change in length. The next thing is to what? Recall that alpha is equal to change in length all over original length times change in theta. You see, the same formula, I modify it like this, I modify it like this. They are still the same thing. If there's a case that need me to use L2 minus L0, I'll put it up there. If there's a case that need me to use what? E, which is the same thing as what? Change in length. Is that clear? Good. So substitute our formula, our values. I have here to be 3 times 10 raised to power minus 5. This is equal to change in length that I'm looking for all over original length, that is what? 100 centimeter multiplied by what? Temperature rise, that is what? 100 degree Celsius. So all I need to do is to cross multiply. If I cross multiply, I have this to this, that is change in length is equal to 3 times 10 raised to power minus 5 multiplied by what? That's going to be 10 raised to power what? 5. Is that correct? Yes. 10 raised to power 4. 10 raised to power 4. So I can have this change in length to be equal to, I don't want to stress you to math, just use your calculator. We have 3 exponential minus 5 multiplied by exponential 4. That will be 0 point something, 0 0.3. 0 0.3 centimeter. So just like if I want to stress you, we have 3 times 10 raised to the power minus 5, then plus 4, which will give us minus 1. We have 3 times 10 raised to the power minus 1 to give us what? 0 0.3. That is, you're using law of indices. Is that clear? So that is for what? This. You can see two different questions, the same formula, but what? Different what? Or different approach. Please take note of this. The first thing you do when you have this kind of calculation or any calculation in physics that involve what the usage of formula direct, always ensure you identify every parameters you need to use. Identify them, bring out your formula, substitute, then and evaluate.